Hi, this is our third video in the series of laws of indices. This These type of questions are involving indices, but they are asking you to solve equations. So we can categorize them as equations using laws of indices. For that, I have a very simple keynote that will work very well for you. It's It goes like that. Variable in the base, you make the power same. Let me give you an example for that. If variable is in the base, let's say x to the power 3 is equal to 8, what would you do? Make the power same. So both sides, you will say that if I can make the same powers, I can write 8 as 2 to the power 3, then I'll use a very simple logic. The logic is I'm raising the same powers and I'm getting the same answer. It means I was using the same base. So that's the example for a variable in the base. The other way around is if the variable is in power. For example, 2 to the power x is equal to 4. Now what? We will make the bases same this time, as it suggests here. Make the bases same. It means I have to write 4 as power of something. 4 as power of 2. 2 to the power 2 is 4. And now the logic is I'm using the same base and I'm getting the same answer. It means I was raising the same power. So these are the two scenarios that you may get for indices as the top level difficulty where your equations, your unknowns have to be found using the laws of indices. But the first thing is variable in the base, make the power same, variable in the power, make the bases same. And this is all done by using preferably prime factorization. Otherwise, you can be clever about using which variable. Here we are using the prime numbers, but may not be prime numbers always. In my examples here as well, we are using two. So we are using prime numbers here. You can see that variable is in the power. So I'm going to make the basis same. I cannot further factorize power base 2 here, but I can factorize 32, and 32 is factorized like that: 2 times 16, 2 times 8, 2 fours, 2 twos, and finally 2 ones. So it's 1, 2, 3, 4, 5. It's 2 to the power 5. And just like before, I'm going to reason like that. I am using the same number, same base, and I'm getting the same answer. It means, it implies that I'm raising the same powers. Whatever the power is on the left side should be equal to the power on the right side. And thus, x equals to 1 goes on the other side and subtracted from 5, we get 4 as our answer for x. Quite easy, yeah, right? Let's see the other part. Slightly more challenging than part A. Um, Prime factorization as is suggested here. So we know that we don't have any power of 4 which results in 8. So if it's an even number, we can always transform 4 as 2 squared. And this has whole power, x plus 1. Similarly, I'm going to express 1 over 8 as 1 over 2 to the power 3. This is power of power on the left side, so it's 2. So powers will be multiplied. Now this one, I need to make bases in the numerator. Whenever I said make the bases same, it means all these numbers, this power 2, this base 2 should be the numerator. How would I get that? If I simply shift it up in the numerator, the sign of the power is reversed, and this is what I get. On the left side, it's 2 power 2x plus 2 if I expand the bracket. And on the right side, it's 2 power negative 3x, because power of power, we multiply the powers. Again, my logic is simple. I've I'm using the same base and I'm getting the same answer, it means I was raising the same powers. So 2x plus 2 is equal to negative 3x, and then it's all algebraic manipulation from here on. Negative 3x on the other side will be positive, which gives us positive 5x, and this 2 on the other side will be negative 2, and hence x is equal to negative 2 over 5. Thank you for watching.